All right, MPLS, multi-protocol label switching. Multi-protocol label switching. This protocol, MPLS, is not a routing protocol. As it is clearly told, it's a switching. And switching based on not MAC address, nor based on the destination IP address, with something special identification called label. I'm not saying MAC address is not involved. MAC address is involved to do switching in the layer 2 level, but there is no layer 3 address involved. So there is a label which is taking the place of the destination IP address. Usually, when we say routing, what does it mean? Based on the destination where the packet wants to go, the routers will show a direction. The routers will have a control plane dictating the data plane how to leave the router. And this control plane and data plane is on every single hop. Based on the destination IP address of the packet, every router, every hop will show a direction, will show an exit interface. So to determine the exit, to determine the direction, it is the destination IP address that is used in normal routing. Whereas in MPLS, routers decides the exit by looking into a small ID called label. Now, why do we need to do this? What is wrong with route lookup? What is wrong with destination lookup? Why we need to do a label lookup? Why we need MPLS? Before answering that, let me finish this. See, this multi-protocol. Again, multi-protocol. This means this routing protocol, this MPLS labeling and forwarding the packet based on the labels can be on any layer 2 encapsulation. It can be Ethernet protocol, encapsulation type Ethernet. It can be PPP or anything. There is no particular environment for MPLS to work. It can work with any layer 2, layer 3 protocols. Unlike frame relay. If you take frame relay, it needs a serial link, an encapsulation type frame relay in order to run frame relay. It needs only serial link. It cannot be done on the Ethernet standard, Ethernet protocol. Ethernet layer 2 encapsulation cannot be a suitable environment for frame relay. Whereas for MPLS, there is no constraint as such. Multi-protocol. Multi-protocol label switching, MPLS. As I said, when you enable MPLS, routers take decision only based on the labels, not based on the destination IP of the packet. How it is better than normal routing? How MPLS improves your network by introducing layer to your packets? Yes, to your packets, additional field, additional thin layer gets added when you enable MPLS. So when you add more layers, it should actually make things more complex, no? Let me repeat. When you enable MPLS, to your 7 layers of your packet, an additional MPLS layer is getting added. But still, this improves the network efficiency. Adding an additional layer is not adding complexity to the routing. It makes the routing easier, simplified, makes the routing simple. How? Few years before, a few months before, we were all carrying one certificate. I am vaccinated. If that is not in your hand, what they have to do is they have to take a test, some test like rapid or whatever. That takes time, no? Normal procedure is testing. But to quicken the boarding process or wherever you go, to quicken the process there, they don't make you sit and wait for the testing result. They don't test even. They say, okay, show me the certificate. Do you have a vaccinated certificate? Okay, yeah, you can go now. See, the additional thing that was added to your packet, vaccination certificate. Maybe you might have used your cell phone to show that you are vaccinated. That additional thing did not make things more complicated for you. It made your thing easier for you. If you don't carry that certificate, you need to go through a testing process and wait for the result. Then only you can proceed like a normal routing. Label gets added to your packet, which was not there in our traditional routing. And because of this label, the routers get a special wisdom of how to route easily. Without label, it has to go through normal route lookup, ceph, fib, and then only packet will go. With label, it gets a special way to quickly forward the packet without wasting much processor and time. How? That's what we are going to see. So MPLS enabled network will be faster. Not only that, the consumption of processor will be comparatively less than the traditional network. So MPLS is an advantage. MPLS is good. How? I have not explained it. I just explained what is MPLS and why MPLS. I also want to explain you the other side of why MPLS. One side we have seen what? Because of adding this MPLS labels to the packets, routers don't take much time to process the packet. Routers move the packet very fast than the traditional network. For example, to make you understand, if traditional network takes 10 minutes, this will take 1 minute. That fast it is. I should not talk in minutes. I should have talked in millisecond. Anyway, you know the difference now. MPLS will definitely improve your network speed. The process utilization will also be less. How it can do, I have not gone to that side. We'll go there. But before that, I also want to add another point why MPLS. The abstraction of physical layer is what today everyone tries to achieve. SD-WAN is what? Abstraction of physical layer. A virtual topology is what everyone likes to have. No one wants to be binded to the physical topology. Everyone needs VPN. Everyone needs virtual tunnel. Everyone likes segments. I'm not teaching segmentation, but MPLS is also a segment. Segment is simply means VPN. Segment simply means tunnel. VPN simply means tunnel. Tunnels provide what? Abstraction from the physical layer, physical topology. Tunnel packets, they don't focus on the physical wire, link, router. No, they don't care about that. They go inside the tunnel. Abstraction layer, virtual link, virtual topology, overlay, underlay, abstraction from underlay. Everyone likes this concept of abstraction from underlay. Maybe even in transport world, abstraction from the roads makes the transport faster, no? Aeroplane, helicopter, jetpack. All these are abstraction from the physical roads. Mosquito helicopter. You can land it in your rooftop. You can fly. Single man only can. It is there in Dubai. You might have seen. You can go to office. No traffic jam for you. No signal problem. You just take off from your rooftop. Land on the office rooftop. For you, parking is on the upstairs rooftop. For others, parking is on the underground. So anywhere you see abstraction like is what makes the transport faster. Abstraction, abstracting from the physical, separating from the physical topology, underlay. Why I'm saying about overlay now? MPLS is the main reason for layer 3, layer 2 VPNs. I just said VPN means overlay. Overlay means segments. Segments mean tunnel. All are same. To achieve this, we have an option with MPLS. That's why we need to learn MPLS. Because everyone understands that overlay transports are much better than underlay than physical layer or physical topology transport. Without VPN, the transport that we have is a physical topology transport, where every router needs to have routes in the routing table to forward the traffic. Whereas when you have tunnels, only the end of the tunnel needs to have complete route information. The middle routers need not to have. See? Definitely this is going to improve your network. Overlay will always be faster than underlay transport. MPLS provides the overlay transport called layer 3 VPN, MPLS, MPBGP tunnel. Also layer 2 VPLS with MPLS encapsulation. So far, what is MPLS? Why is MPLS? Is what I have explained to you. Now what I'm going to do is how MPLS makes the routing faster. How MPLS can reduce the amount of process utilized as I said earlier, when we enable MPLS, every packet will have MPLS layer added. This MPLS layer will have labels. So a packet is now coming with a label sent from an MPLS router. This MPLS router only can add MPLS layer to the packet. A traditional normal router without MPLS have nothing to do with adding label. And this label, when the receiving router see this label coming in the packet, just by looking into the label only by looking into that label, the receiving routers know now what to do with the packet. They no need to check the big, see how big I told, big layer 3 header. Every router in the path no need to process the big layer 3 header. It needs to simply process that simple 32-bit MPLS layer, and it will be comfortable to decide the exit. That will be more than sufficient for the router to decide the exit. Without MPLS, every router need to process that big layer 3 header to decide the exit. Without MPLS, in a traditional routing, every router needs to process the every packet's layer 3 big header with multiple fields in it. Multiple fields. Multiple fields like offset, TTL, length, optional field, version field, and TOS field, fragment field, source IP address field, destination IP address field, protocol field. All these fields, every router will be reading on every incoming packet. Think about the time taken. Just to know one information where I have to send the packet, why every router need to read all this field? Not necessary. MPLS avoids that wasting of time. MPLS avoids that unnecessary lookup. How? MPLS, by giving one label to the packet, that label has got a meaning. When a router receives a packet with a label, when it sees the label, it understands the meaning of the label. The label, this label number 50, it means the packet is for destination maybe 8.8.8.8. So I need to send via F00. It will send. So the same routing that the packet used to be undergoing, the same path, now is given by looking into a simple label, not by reading the big layer 3 header. Understand this. For that, I'll give you another example, which I always use in my MPLS class. When you board a flight, behind your ticket, they put a label. And the same label will also be in the destination computer. Not only that, on your baggage. When you check in with the baggage, 60 kilogram. Okay, fine. They put a label behind your ticket. Similar label will be there on your baggage, and it will also be there on the destination airport computer. So when the baggage reaches the destination, in the cargo hold. Via the cargo hold, you didn't carry the baggage. You just checked in. So you wait in the belt area. And your baggage did not come. Everyone left. The belt is empty. The baggage did not come. And you go and ask the airline office there. Let's say you use Emirates. Then in the airport there will be Emirates booth. You go and ask them. They will very clearly say, yes, your baggage did not come in this flight. How? As the bag gets into cargo hold, they know whose bag has gone inside and whose bag has not gone in. You checked in with 60 kg. Everyone is checking with 60 kg. Then where is the space in the cargo hold? So what they did is they left your baggage because there is no space in the cargo hold. And they already know it, they have left it. But you know only now, after you landed in the destination. How they know they have left your baggage? Because your ticket backside label is matching with their computer baggage list, which is coming in another flight, not this flight which you came. So they are very clear. See, they have never seen you before, but they say clearly, yes, sir, your baggage didn't come in this flight which you used, which you came. Because of overloaded, we have put it on another flight, which will be arriving this afternoon. Don't worry, give me your address, we will deliver to your home. And they deliver to your home. You see, because of the label, the handling was very easy. Assume that there is no labeling. What they would have done, after you board the flight, before takeoff, they might have announced you. They might have announced every passenger. Hello, passenger, look through the window. Do you see one bag there outside? Whose bag is that? Please come out. They will call you. And you deboard the flight and then you identify, yes, this is my bag. What is the issue? Sorry, sir. There is no space in this cargo. Please allow us to send through the next flight. Anyway, you will say yes only. And you will say yes. And then they would have put in the next flight. Now, again, there will be a problem for you. Why, when you land, your baggage didn't come with you. You know very well your baggage didn't come with you. Now, how you will make the airport guys to understand that my flight, my baggage is coming in the next flight? What is the record there? How will you prove that it is you, the one who is the owner of that baggage which is coming in the next flight? Only when you have label, you don't need to stick much. Just show the label and they check their computer and they say, sir, your baggage is coming in the next flight. We'll deliver to your home address. Just fill this form, we'll do it. See, the labels makes work easier. Otherwise, it's very difficult. Maybe they might have done, if there is no labeling system, they might have put you next to flight because there is no space for your baggage in this flight. Very difficult, no? See, the label provides the abstraction. Because the label is there, that the flight and the baggage is not tied up now. The baggage can be tied to any flight which is available. You flight and baggage is not tied because you all have different label. Sorry, you all have same label. Even if it is sent in different transport, it can be reunited in the destination. But this example I never used in my past delivery. I started with something which I used to deliver regularly, but it took me to some other direction. Anyhow, the message is conveyed. Because there is a label in the box, you can easily identify your box. You no need to open your box and check whether these are all your things and then say, yes, this is mine. No one needs to open the box. They just collect your ticket. If there is a confusion, if there are two baggages similar, two passenger baggages similar, appearance, same color. If you have a confusion, very easy to identify. Just flip your ticket, check the label in the baggage. If it matches, then it's yours. If it is not, then it belongs to the other guy. The other box is yours. It saves time, you know. Otherwise, you need to open the layer 3 header. Zip. Is this my thing inside? My pant, my shirt? Oh no, these are all not mine. Again, zip it back. Open the other box. Unzip. Check the material inside. Yeah, this is mine. It's very difficult. Because of that one single label on the top, you don't need to open the box. Even if all the packets, all the baggages that checked in that day is pink color, same size, same company, American Tourister, you will not have any confusion. Because your label on your ticket and the baggage on your ticket matches. Label on the baggage and the label on the ticket matches. Exactly the same thing. When a packet arrives with a label 20, router already have got information 20 means the packet needs to go to destination 8.8.8.8 this way, F00. So when the packet arrives with the label 20, this router 1 knows that I need to send through this way because 20 means it is for destination 8.8.8. So to know the destination and the exit interface, this router did not read the layer 3 big header. The layer 3 big header has got destination IP. It did not read that. Just by looking into this 20, this 20 matches with this baggage label 20, which means this baggage belong to 8.8.8.8 destination. I need to forward the packet via this direction. Label quickens routing, but we don't call it as routing, we call it as label switching, because there is no layer 3 address involved in deciding the exit interface. Fine. More about this will come anyway in daily class. So let us now jump into the MPLS header format. MPLS header. MPLS header is a simplified header with only 32-bit. The entire size of MPLS header is 32-bit only. But if you take layer 3 header, one IP address itself is 32-bit. Source IP address is 32, destination IP address is 32, TOS type of service bit is 6 to 8, version, option field, protocol field, fragment field, TTL field. How many? That will be thousands and thousands of bits you need to process if you don't have MPLS. You need to read the big layer 3 header just to know one information, destination IP. Now, because of MPLS, you simply decide the route by looking into this simple label. So you no need to read that layer 3 header now. So all that you need to know is the label. MPLS uses only 32-bit, in which first 20-bit bits for label. And then 3 bits, you can use it for class of service. You may also use it for TE, traffic engineering. Because you can use it for various things, it is called as experimental bit. Experimental bit. After this comes 1 bit that is to tell whether we have many MPLS layer in this packet or single layer in this packet. If you would have done VPN, layer 3 VPN, any layer 3 VPN, it may be GRE or IPsec, you might have noticed that there will be 2 layer 3 header, inner header and outer header, 2 layer 3 source address, 2 layer 3 destination address, 2 layer 3 header. Likewise, when you do MPLS VPN, here also you will be having more than one layer 3 MPLS. Instead of IP header, you will have MPLS header. So now this bit is called as bottom of stack bit. This is to tell that this is the last layer of MPLS, or there is another layer of MPLS. Just to say whether it is a bottom of a stack or not the bottom. Bottom of a stack means what? This is the last layer. If that 1 bit is on, then this is the last MPLS layer. The one which I am processing is the last. If the bottom of a stack bit is 0 instead of 1, then it is not really bottom of a stack because it is 0, which means what I am processing is a transport label. It is not a service label. It's not a VPN label. It is not a bottom. It is not a bottom. So whether to know whether it is a bottom or not bottom, we need a bit, and that bit is what? This bit, 1 bit. At last, the fourth one is 8-bit. See, out of 32, 20-bit is for labels, 3-bit is for experimental, COS or TE, 1 bit, bottom of a stack, and 8-bit is for TTL. You see, in layer 3 header, we have TTL, time to leave. The time to leave is very good, which you cannot avoid. See, you can avoid layer 3 header. You can avoid looking into layer 3 header because you get the information by looking into this MPLS header. You know the destination just by looking into MPLS header. So you may avoid all other fields of layer 3 header, but you cannot avoid this TTL field of layer 3 header. This TTL field of layer 3 header is very important because the only default loop prevention mechanism that we have in IP packet is the TTL which is present in layer 3 header. After MPLS, we saw that our routers are not going to look into layer 3 header. Then you will lose that advantage of TTL, which is very important. You cannot lose it. We want it. So MPLS is designed to copy the layer 3 TTL into MPLS field. So you don't have any compromise here. You got the same quality of loop prevention and you got better quality in routing. MPLS is 32-bit only. The entire MPLS header is 32-bit only. But whereas IPv4 header will be thousands. So it depends because there is a field called optional field which will have a lot of junk fields. There are a lot of fields like fragment and this and that. No. So now routers are not going to process that big field, the big header. It's going to process only the simple 32-bit header and take similar decision what a normal routing can decide. So if I want to use MPLS and avoid layer 3 lookup, layer 3 header reading, if I want my router not to read the layer 3 header of the incoming packet, then MPLS should be before layer 3. Only then, by just looking into this MPLS header, I will know the destination. This MPLS header cannot be after layer 3. It should be before. Yes. We have application layer, presentation layer, session layer, transport layer, network layer, MPLS, data link, physical. So MPLS is before layer 3. MPLS is before layer 3. So before layer 3 itself, MPLS layer is there and the label is there. And with the label, the routers will be able to conclude the direction of the packet. So there is no need to look into network layer. There is no need to read the layer 3 header of all incoming packet. So some people.
So,
yes, sir.
Sorry, question. Is there any bit which tells the router that don't look any further?
No,
is it just the label?
Just layer. There is no bit. There is no bit to say that you no need to look into NL. In data link layer, definitely there is a MPLS marking. In data link layer itself, it knows that I'm having MPLS, and there is no other marking in MPLS layer to say don't look into layer 3. No, there is nothing like that because it gets enough of information right here itself. It won't go to layer 3 header.
Okay, so the MAC layer will have some field which will say I'm carrying MPLS packet.
See, we have
Uh,
something called opcode or something like that.
okay, okay,
That will be in hexadecimal. That will be different for MPLS and IP. For MPLS, it will be different, and for IP, it will be different. There will be a marking in data link layer.
okay, okay.
It will be in hexadecimal format. Yeah. So,
And
yes, please.
so one more thing. So you mentioned this is an overlay thing. So is it always
No, 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 no,
required
no,
that
no,
there
no,
is always
no,
an
no, no, no,
underlay?
no. Overlay can be achieved through MPLS. MPLS is not overlay. MPLS with
Okay,
MPBGP. MPLS with MPBGP can provide you overlay service. That's what I mean.
okay.
Yeah. So far we have seen what does MPLS stands for, why MPLS, and how MPLS. More about how MPLS we'll see in coming days. Very important in this MPLS class is layer 3 VPN, which is coming later. But today class is also very important because it has given you very good input of why and how and what.